The fish are having a tough time. The dry season came up really fast and really hard this year, and the pond is drying out. There is very little water. So we're going to add just a bucket once a week. But as you can see, there's also a lot of filamentous algae. And this is taking up a lot of space for the fish. So we're going to try to kill this filamentous algae. For that I'm going to use hydrogen peroxide. As you can see, I have here a bucket of water which I'm going to pour into the pond, and also here I have a measuring cup and some hydrogen peroxide. Now the thing that worries me the most about this is that this algae is providing a lot of oxygen for the fish, and when you kill the algae suddenly, abruptly, you risk that your fish won't get enough oxygen and may die. Also, these fish are quite sturdy, they can handle that. What I'm worried the most is my shrimp. The shrimp really needs a really good oxygenated pond. So yeah, I'm going to go easy with this hydrogen peroxide, and I'm going to add about 5 milliliters of hydrogen peroxide. Oops, maybe a little bit more. Doesn't matter, I'm going easy with it. Because the dosage is about half a cup, 125 milliliters per 400 liters of water. And I estimate that this pond has about maybe 100 liters. If it doesn't work at this dosage, I'm going to increase it slowly. But to mix it very well, I'm going to add this hydrogen peroxide to this bucket of water, and then we're going to pour the bucket of water in the pond. Okay, so here we go. All right. Yeah, I think with just a bucket of water every week will be enough to sustain this pond, this little ecosystem, until the rains come back. And I believe the hydrogen peroxide will only kill the filamentous algae. The Elodea and Vallisneria, I hope they will be okay. The fish, I hope they will be okay also. And maybe, I don't know, in addition to the shrimp perhaps being a little bit stressed about the hydrogen peroxide, I'm also worried about the snails. But for now we don't have any other thing to do than to wait. I can see both half big fish are still alive. All the mollies are still alive. The zebrafish are also still alive. The mollies, however, are not producing any more babies. And the zebrafish, well, those have never been producing babies. I think I only have one adult one. That yellow one is the adult, and the other ones are still juvenile. So it's been 24 hours, and as you can see, nothing happened. So what we're going to do next is we're going to test the different concentrations of hydrogen peroxide to try to estimate how much do we need to kill this algae. So I'm just going to place it in here in this petri dish, and let's take a sample. Oh, look! Look! Do you see that? It's a damselfly nymph. So we're going to return that one. Yeah. Wow, a bunch of things are coming in here. Also here we have some, I guess these are chironomids, maybe. Oh, there's a bunch of stuff in here. At some point we will have to look under the microscope what's in here. But for now I want to get rid of this algae. So let's go to the tests. Oh my god, there are actually a lot of damselfly nymphs. And also we have some chironomids here, as you can see. And two nymphs, a shrimp. There's a lot of biodiversity here. First we're going to test a really wide variety of concentrations. And for that I have placed here 2.7 milliliters of regular tap water, this one. And now we are going to add 300 microliters or 0.3 milliliters of hydrogen peroxide to the first one, like so. We are going to take 300 microliters and place them on the next one. We're going to mix the solution really well. Take another 300 and repeat. With this we're going to make a 10-fold series, dilution series. The last one we can leave it there. And you know what? I'm going to test another one without any dilution, because this hydrogen peroxide actually is quite old. So maybe it's just flat, completely flat. So we are going to add 3 milliliters into this one. Alright, so here we have our solutions, and now we are going to place approximately the same amount of algae into each one of these test tubes. The ideal thing will be to weight the algae, so each tube has the same grams or the same weight of biological material, but I currently don't have one scale, weighting scale, so we are going to just add it. Try to add the same amount on each, and I'm going to add first on the most diluted tube. Okay. Oops. I'm already messing up the experiment. I expect to see some bubbling. That will mean that there are actually bacteria here with catalase activity. Catalase is an enzyme that breaks hydrogen peroxide, and it breaks it really fast, so we can see how oxygen bubbles are produced. But so far we are not seeing anything. Okay, let's see the undiluted one. Now I think this is completely flat. It's completely flat. Oh, we see some bubbling. We actually see some bubbling. Do you see? There? Yeah. No. It's working. Do you see the bubbles evolving? Yeah, but this one is straight from the bottle. Straight from the bottle. That is too much. Imagine if only this one worked. This one, the 1 in 10 fold dilution, is also developing some bubbles. And the last one is doing nothing. I guess, let me see with the camera. Yeah, the most diluted one is doing nothing. So we're going to wait 15 minutes, perhaps half an hour, and we're going to see which is the minimal concentration that showed 100% killing of the algae. So we can then calculate how much we need to add to the pond. Okay, so after 20 minutes we can see that the most diluted concentration did nothing. The following 3 also did nothing. The next 2 ones apparently did nothing also. But the 1 in 10 dilution showed some bubbles. But the algae, I think it's still alive. And when I use it as it came out from the bottle, I guess it was the best one. However, I cannot use it as concentrated as in the bottle, because first I will need a lot, and second, I mean, this is pure hydrogen peroxide at 2.5 to 3.5%. So to add this to the pond, I will need to replace all the water with a solution of hydrogen peroxide that is at this concentration. That is not feasible. So maybe it will take a more time. So while this is incubating, what I'm going to do is to prepare a second dilution series, but now I will dilute it twofold. So I will start with the hydrogen peroxide as it comes from the bottle, and we're going to prepare 7 twofold dilution series. Okay, so let's do that. We need 7 tubes. We need to add water first. So we're going to add 2 milliliters here, 2 milliliters here, and so on and so forth. And then we're going to do the twofold serial dilution by transferring 2 milliliters from the previous tube to the next one. Alright, and yeah, look at this. Apparently there was a dragonfly nymph in this chunk of algae, but now it's dying. I don't know why. It's dying, poor little thing. And look how many snails are coming out also. Man, this pond is full of life. It's full of life. Okay, so now we are going to add the algae. Another thing that we will need to take into consideration is the amount of solution, because we see here in the, for example, 1/10 fold dilution, that it's actually killing the algae. However, the relation between the hydrogen peroxide solution and the amount of algae we have here is too big. So maybe that's the optimal concentration, but it simply doesn't have enough. It simply doesn't have enough amount of solution. Yeah, I messed it up here. You see, I'm totally messed up this experiment already. Here I have more here and I don't know why. That means that I only transferred 1 milliliter from here to there, so these one are actually not a two-fold dilution series. Look, this one is working. Oh well, we're going to repeat the experiment anyways. So yes, I was telling you, maybe this is the correct concentration, perhaps, for example, maybe this one, 8-fold dilution is the optimal one, but in this little test tube it will not kill all the algae simply because there is too much algae here. So we need a bigger volume at this concentration to effectively kill all this amount of algae. That's why it's important to always weight your biological material to establish these kind of relations. But for the moment we're going to leave it like this, and we're going to wait 24 hours to see what happens. Look at that, you can see it bubbling. You can see it bubbling. But yeah, definitely I added way too little hydrogen peroxide the last time we did this. I added 5 milliliters of hydrogen peroxide, then I diluted that to 16 liters, and then we added those 16 liters to the pond, which I estimate, I said 100 liters, but no, that's too much. Maybe it has 40 liters, maybe 50 liters of water. That means I diluted it like 1 in 1,000. Yeah, 1 in 1,000 dilution. So it's too much, simply too much. Too much. It was diluted too much. So yeah, I'm going to return these animals to the pond and we will see what happens in 24 hours to these tubes. So these are the results so far, and as you can see in the 10-fold dilution series, the effective one was obviously 1 in 1, but also 1 in 10. That means diluting the sample, diluting the hydrogen peroxide 10 times is still somewhat effective. It didn't kill all the algae, but we see some dead material in here. The 1 in 100, 1,000, 10,000 dilutions didn't work out. And in the 2-fold dilution series, we can see that even 1 in 12 dilution, that is diluting the hydrogen peroxide 12 times, caused the algae to die partially. You can see that lysate. Yeah, even 1 in 24, but yeah, these are no effective because we need to achieve a 90%, about a 90% of dead algae. Killing 100% of the algae is practically impossible. We might endanger the other species living in there. So this is only half of the story. What we need to estimate now is the dose we need to add. And for that, what we are going to do now is to, as I said, the ideal thing will be to weight the amount of algae, but I don't have a weighting scale at the moment. So I just, by eye, cut little pieces of decreasing size, and we're going to test a single concentration that I think it will be 1 in 12. Diluted, the hydrogen peroxide diluted 10 times. We are going to test the same volume of hydrogen peroxide diluted 10 times with different amounts of algae. So we can estimate the dose of milligrams or milliliters of hydrogen peroxide at the desired concentration per gram of algae. So this time we are going to add the algae first, and then I'm going to prepare a stock solution of hydrogen peroxide diluted 10 times, that is between an actual concentration between 0.25 to 0.3%. So 2.5 milliliters of hydrogen peroxide and what it needs for 25 milliliters. Whoppa! Okay, so here we go again. Alright. Careful, careful. That's it. Alright. We are going to wait 24 hours and let's see what happens. Alright, it's bubbling already. Can you see that? Can you see that? As you can see, this hydrogen peroxide concentration and volume was only able to kill the lowest amount of filamentous algae. The next amount, a little bit more, was also pretty successful, but there are still some. And the next one, yeah, there is still filamentous algae there. So this means that I will have to use quite a lot. Now I understand why the hydrogen peroxide used in ponds comes in a 10-15% concentration, whereas the hydrogen peroxide used for wound cleaning comes at max 3%. But yeah, I think we will have to use quite a lot. Now, as you can see, I don't even have enough for this pond. So, however, I don't want to actually kill all the filamentous algae. I just want to get rid of some of it so the fish can have a little bit more space to swim and to do their stuff. So we're going to kill as much as we can, and then I will be removing the rest of it, or as much as needed, by hand with a simple stick. Since I don't have a weighting scale, I don't actually know how much hydrogen peroxide do I need. Nevertheless, with this hydrogen peroxide concentration of 2.5 to 3.5%, it's not even enough. I will need to use actually about 2 liters of this stuff to get rid of 90% of the filamentous algae. So I don't know, let's see how much do we have. Yeah, 160 milliliters will be a dilution of 1 in 100 with this bucket of water. And when we add that bucket of water into the pond, that will be about 1 in 1,000 dilution. So yeah, it's not nearly enough. Maybe we are going to add it all. Okay, a little bit more than a quarter of a liter. Should we go with that? Okay, let's try it. Let's try it, because yeah, this fish And as you can see, these fish they simply don't have enough space. There's a lot of organic matter falling into the pond. And this will be also a problem because, you know, that filamentous algae is growing precisely because there is an excess of nutrients, an excess of nitrogen in the form of nitrates, a lot of carbon in the form of leaves. But I'm hoping that if we get rid of some of it, that floating plant, I don't remember its name right now, will start to colonize also the Elodea and the Vallisneria, will take up some space. And also, I don't want to get rid of all of it because, you know, that is also natural, but also because the mollies and the snails actually eat these filamentous algae. And one problem that I'm expecting to see is that once killed, it will regrow pretty fast, exponentially. And it could be that the problem worsens. And that is because all that algae, when it dies, it will release a lot of nutrients that will be causing the algae to grow again. So removing it by hand, I think, will be a must in order to keep it in check. So yeah, let's go ahead and add all this stuff. Oh boy, it's even turning yellow. Look at that. Did you see that? Okay, I hope my shrimp will be alright. Here we go. Oh boy. Oh boy. And the problem with hydrogen peroxide is also that it kills beneficial bacteria, it kills protozoa, it kills everything. It's not selective. However, the threshold is different for each organism. Do we see some bubbling? And also a bunch of animals are falling here. You know, wasps, bees, and other types of animals are coming here to have a drink. And when they sometimes get trapped, like that one, you see that one? They get trapped and drown, and that contributes to the problem. Because the problem with this pond is that it has too many resources, too many nutrients. So let's see what happens. Ooh, we are actually seeing some bubbling. You can see that? Can you see that? There is some bubbling there. I hope that is the hydrogen peroxide and not just the bubbles that were trapped with the sediment at the bottom. No, that surely is the hydrogen peroxide doing its thing. Yeah. I think it worked, guys. It was not perfect. I didn't add enough hydrogen peroxide, but now the fish have a little bit more space to do their stuff, especially here. You can see the Vallisneria, Turk. You can see the Vallisneria, and this remaining algae, I just can use a stick like so to remove it. And if things get worse, I may add a little bit more hydrogen peroxide, I don't know. For now, I'm going to use this stick. I think it's the most effective way. I haven't seen my shrimp though, but I guess they are fine. And the snails are there. The snails are fine. Oh no, guys, look at this. This is one of my shrimp. They died. It was too much. It was actually too much. Oh no. Well, lesson learned. Too bad. That's why I always say natural methods are always far, far, far better than any chemical you can add. So from now on, I'm going to try to add more plants. Maybe clean a little bit of this leaf litter, and remove some sticks. And use my stick. That's the most effective way to get rid of this. Yeah. Well, shit happens. I can always add more. The fish are okay though. There are the 2 half beaks, there are the zebrafish, and the mollies. I have also seen them. My precious shrimp.